everyone. So because I know people are anxious to move on, I thought I'm just going to do a video on the trapezium rule because it's not that difficult really. It's something, I think you've already seen it before at like GCSE to a certain level, and it's basically the same thing here. So instead of integrating something to find the area under a curve, you basically use the trapezium rule and split a curve into loads of little trapeziums and basically find the area of the trapeziums. So as it says here, you use it for functions that can't be integrated. You find the approximate value using the numerical method, which basically you split the curve into little trapeziums and then you find the area using the trapezium rule. So it says the the equation for it here, and this, you are given this in the formula booklet, so you don't need to remember this. It looks kind of complicated, especially like with this H thing, but it's a lot easier, I think, looking at a diagram of it. So I'm just gonna show you this, and hopefully this will make a little bit more sense. So looking at this curve here, so the idea is that we are splitting that curve into trapeziums like so. And the idea is that this width here is the same each time. And that is basically, I know they're not exactly equal here, but that's the height of each trapezium. So the idea is the trapeziums are sort of looking like this. They're sort of upright like this, where this is the height and these are the other two sides, like so. So when it says b minus a over n, it's literally just talking about the two intervals here. So say this is b and this is a. It's basically just splitting that gap there. It's splitting it between how many intervals or how many trapeziums you've got. So n is basically, n is the number, the number of trapeziums that you've got. So that's basically what that is saying. So here we'd be splitting, the height would basically be b minus a divided by 4, because I've got 4 trapeziums there. And then the reason why, so we've got here y0 and yn. So y0 would be this line here. That would be y0, that line here. And yn would be the final one here. And it's basically because they are only part of one trapezium. They're only part of the start trapezium and the final trapezium. Whereas these lines here, so say this is like y1, this is y2, and so on. This line is part of two trapeziums. It's part of this, say this is trapezium 1 and this is trapezium 2. Y1 is part of trapezium 1 and trapezium 2. Same as Y2, it's part of trapezium 2 and trapezium 3, which is why they're all multiplied by 2, because when we're basically just adding up a bunch of trapeziums, because the area of a trapezium, of just a basic trapezium, is half A plus B H. So we've got the half H is here. And then the A add B bit, this is all basically the A add B bit here. That's the A add B bit. So we're adding basically all those values, but as we said, the A and B values, y1 and y2, are going to be in two trapeziums, which is why they all need to be doubled, whereas y0 and yn are only in one trapezium, so they don't need to be doubled. So that's where the formula comes from. And I think, yeah, it's just a bit easier to visualise it when you can see it. Basically, it's a lot easier to visualise. So let's have a look at this one. So this one doesn't have a curve, but it might be easier for you to visualise if we draw a curve. So I might just draw a curve just to show you. So, I mean, we know an exponential is going to look something like this anyway. So say, for example, we want it between 5 and 3. So x is 5 and x is 3. Like so, and we're splitting it. It says into 4 strips, so we want 1, 2. I probably should have made the gap between them a little bit bigger, so let's do that. Let's make the gap between them a little bit bigger. I'm really tailing off there, aren't I? I have no idea if this is what it actually looks like, but there you go. We'll split it into 4 trapeziums there. So x is basically the limits, so 3 and 5. And then y will give us the a and b values, because again, the trapezium was sort of looking at it like this. So these are like the a and b values, and then these are, and this would be the height of the trapezium here. So the heights are going to be y's. So a and b are both going to be the y values at those points at the x coordinate. So then we're splitting it into 4 strips. So to find the height, so basically we're going to go up in whatever the height of the trapezium is. That's going to be like the intervals that we need. So to find the height of the trapezium, that's just going to be 5 minus 3 over 4. So that's the gap between the intervals divided by basically the number of trapeziums. And literally I can't be bothered writing the word trapezium, so I'm just going to draw a trapezium. So 5 minus 3, 2 divided by 4. So the height is 0.5. So that tells us the intervals that we need to calculate. So we're going to need 3.5, 4, and 4.5 there. So this would be 3.5, this would be at 4, and this would be at 4.5 there. And you can see that the height between all of them is a half, which is what we wanted. So then all you are doing then for this, you're just substituting those values into y is equal to 3 to the power of x. So this first value here, I'm just going to put 3 to the power of 3, which would be 27. And then I'm doing it to the power of 3.5. Now I'm just going to do it to 3 significant figures. So sometimes it will tell you, but if in doubt, I'd probably just do 3 significant figures. So that's 3 to the power of 3.5, because remember it's this thing here that we're using, which that's where I've got 3 to the power of x from. So this is just 3 to the power of 3.5, 46.8, then 3 to the power of 4, which is 81. So I'm just literally substituting the x values in. Then 3 to the power of 4.5 is 140. Sorry, I'm just going to write it here so it doesn't overlap. And then 3 to the power of 5 is 243. And then we're just bunging it into the formula. So the formula was up here. I'll just put it there so you can actually see what it is. So it's h over 2. So that would be a half divided by 2. You can write that if you want. Oh, if I have my pen at least. So it's a half over 2, or a half times by a half. And then it's times by. So remember the first and last values for y. This is y0. That should be a y. There we go. And that is y to the n. The first and last values of y, because remember, they are only in one trapezium, if we can see here. So this value here, yeah, let's use a different colour pen, why not? So that's y0, and that's yn. The first and last ones are only in one trapezium, so that's why those values only show up one time. So let's go back over here. So the first and last values, so that's 27 plus 243. And then it's twice all the other ones because they are in 2 trapeziums. So because they're the smaller height of one trapezium and the large height of the trapezium before it. So it's 2 lots. It's not 27. I've literally just said that. It's only in one trapezium. Let's try again. So 46.8 plus 81 plus 140. And that's it. So that is roughly the error. So it's a wiggly bracket. Because again, it's an approximation at the end of the day. So if you bung all that into your calculator, I get 201.4 when I do that. That is supposed to be a 4. Sometimes this pen doesn't write very well. So that's 201.4. So hopefully you can, if I zoom out a little bit, you can see the whole thing there. So just to sort of reiterate, so what we did there is we knew we wanted it in 4 strips. So what we did is we took the gap between the intervals, so 5 minus 3, 2, divided that by 4. That told us the height of each trapezium. The height of each trapezium is 0.5, and that told us what values of x we needed to go up in. So x went up in 0.5s, like so. And then we substituted in our x values into our 3 to the power of x to get our y values. They were the a and b values of our trapezium. And then we put it into the formula like so, with the first and last values only being used once and all the other values being used twice because they're in 2 trapeziums. Right, we're going to have a look at one more example, which just has a little bit more info, but it's basically the same thing. So here we have y is equal to sec x. The finite region is bounded by the curve on the x-axis, and the line x is equal to pi over 3. So we're only integrating between 0 and pi over 3. So you can see this table's already been filled in for us. So x is 0 is here, and then we've got, I think we've got 4 strips, because we can see here these values would be for trapezium 1, these values would be for trapezium 2, these values would be for trapezium 3, and these values would be for trapezium 4. So you can see you've got 1, 2, 3, 4, 5 values. So it's basically the number of values minus 1. That's how many trapeziums that you've got there. I'll get rid of those. But we're splitting it into 4 trapeziums again. They're not equal at all. And we can see the gap between the intervals is pi over 12, because we can see there between 0 and pi over 12. That's a height of pi over 12. Pi over 6 minus pi over 12, the gap would be pi over 12. So that's our height of our trapeziums, is pi over 12. So h is pi over 12 there. So, as I say, we just substitute in our x values to get the heights. So this has a height of 1, which we can see there. That has a height of 1.035. Oops. Because that's what you get when you substitute in pi over 12 into y is equal to sec x. You can check that if you want by putting that in on your calculator. And then this pi over 3 here, that would have a height of 2. So we just need to find the missing values. So what we need to do here is, I'm just going to zoom in. So to find this missing value, we're just going to do sec, it is sec, isn't it? Yeah. So this value would be sec to the pi over 6. And this value here will be sec to the pi over 4. So we just need to find those values by substituting them, those x values in for y. And that is going to get us 1.155. And when we substitute pi over 4 in, that's going to get us 1.414. I have already pre-worked out these values. I didn't just like do that in my head or something like that. So I get those values there. So say they will be the other A and B values. So then we completed the table. So now we use the trapezium rule to obtain an estimate of the area. So for part B of that question, we're just using our formula from before. And to be honest, when you understand it, you don't even really need the formula. But obviously it will be in your formula booklet if you need it. So it's the height divided by 2. So it's pi over 12 divided by 2, which would be pi over 24. But you can do a half times by pi over 12, it doesn't really matter. And then the first and last value is y, so it'll be 1 add 2. And then it will be add 2 lots of all the middle values. So 2 lots of 1.035 plus 1.155 plus 1.414. So it will be that. Yes, I think that's enough brackets there. And then all you need to do there is just bung that in on your calculator. And I realize I should really use the wiggly brackets because again, it is an estimation. So that gives us an approximate area of 1.34. Again, 3 significant figures if you're not told otherwise. And that's our area. So that's part B. And then part C, it says explain if this is an overestimate or underestimate. And this is basically looking at the geometry of the graph. So again, I'm just going to go over here for a sec and explain what I mean. So I'm going to draw 2 curves like so. So this is a convex curve. And this is concave. And again, the way I remember it is a concave looks like a cave, as in like you could get under it, you could get in that cave, whereas convex, you can't. So what I'm going to do is I'm going to draw 2 points on each one. And for trapezium rule, we're literally drawing trapeziums. So say our curve is here, we are basically just drawing little trapeziums. So there's going to be a straight line connecting those 2 points together. And the shape of the curve will tell us if it's going to be an underestimate or overestimate, because basically is the line going to go above or below the curve. So for a convex, if we just join those 2 points with a straight line, we can see, and like that was our trapezium, we can see that's an overestimate. So a convex, if it's a convex curve, that will be an overestimate, because we can see the trapezium, the lines connecting it will go above the curve. And then for a convex, we can see if we join those 2 points together, and then that's our trapezium, we can see that the curve is bigger than the trapezium. So if it's concave, it would be an underestimate. So that, again, it's sort of just common sense. It's just looking at what your curve looks like and seeing, well, is the trapezium going to be bigger than the curve, or is the trapezium going to be smaller than the curve? So convex, it will be an overestimate. Concave, it will be an underestimate. So if we have a look at sec is convex. Y is equal to sec x is a convex curve. I'll zoom out a little bit so you can see what's going on there. So part C, and this is where I've got to try and write. So it will be an overestimate. So our solution, or our estimation, it will be an overestimate because y is equal to sec x is convex. Because y is equal to sec x, I've just, oh, that's not what I meant to write, was it? Whoops. Ignore that. Y is equal to sec x is convex. Let me just move that out of the way, that's annoying me. So y is equal to sec x is convex. Go away. So y is equal to, I don't know why I'm writing my x's like algebra x's, but anyway. So y is equal to sec x is convex. So line connecting the points. So line connecting, again, I struggle to write with this. So line connecting the 2 points will be above the curve. Will be above the curve. So that is basically the trapezium rule. So as you can see, it's not really difficult. It's literally just splitting the curve into little trapeziums and finding the area of them. And like I say, the only other thing you really need to remember is if it's an overestimate or underestimate, and that will be to do with the shape of the curve. In a test or an exam, if you can't remember that, draw that diagram and logically connect the points, and you'll see if it's an underestimate or overestimate. And then to practice that, you've got in the book exercise 11, I want to say that's 11I. Anyway, it's on page 319, questions 1, 2 and 3, if you want to have a practice of that. But that's basically the trapezium rule. If I just do that, there you go. That's everything we really need to know about the trapezium rule.